A coin spins in the air, suspended in a blur of motion. It hasn't yet chosen sides, heads or tails. In this moment, it's both. This simple image captures one of the most mind-bending ideas in quantum physics: superposition. Just like the spinning coin, a quantum particle exists in multiple states at once, until it's observed. Welcome to the strange and powerful world of quantum physics, where the rules of classical reality bend and twist. At its core are concepts that defy intuition: quantum entanglement, where particles remain mysteriously linked across space; wave-particle duality, where particles behave like both waves and matter; and the uncertainty principle, where the more precisely something is measured, the less certain we become about something else. Now, imagine harnessing these bizarre principles, not just to understand the universe, but to build entirely new technologies. Enter quantum computing. These machines don't just process ones and zeros, they process infinite possibilities simultaneously. It's not science fiction, it's already reshaping our approach to complex problems. In drug discovery, quantum computers are unlocking new molecular combinations, potentially cutting years off the development of life-saving treatments. In materials science, they help design stronger, lighter, and more efficient materials at the atomic level. But the implications don't stop there. Cybersecurity may never be the same. Quantum computing can both break traditional encryption and create systems resistant to any future hacks. It's also pushing the boundaries of artificial intelligence, accelerating learning and optimization in ways traditional supercomputers can't match. Beyond computing, quantum principles are also transforming how we sense the world. Quantum sensors detect subtle changes in magnetic and gravitational fields with astonishing precision. In medicine, they could enable real-time brain imaging with zero invasiveness. In environmental science, they're improving how we monitor climate systems, detect underground resources, and even predict natural disasters. Future aircraft and submarines may rely on quantum sensing for navigation, without GPS. Deep space communication, emergency response, and even smartphone technology will benefit from this ultra-sensitive detection. Then comes the frontier of quantum communication, where unbreakable encryption becomes reality. Unlike traditional data transfer, quantum cryptography uses the laws of physics, not algorithms, to guarantee security. Any attempt to eavesdrop instantly disrupts the data flow, making tampering impossible. Nations are already building quantum networks, aiming to secure government files, protect financial transactions, and even guarantee the integrity of elections. It's a future where privacy is baked into the fabric of communication itself. The momentum is undeniable. If you are enjoying the content, please hit that like and subscribe button to support us in making more such content. Governments, startups, and universities around the world are pouring billions into quantum research and development. We're standing at the dawn of a technological revolution that will change medicine, computing, communication, and more. But with great power comes great responsibility. As we push the boundaries of what's possible, we must also consider the ethical implications, from privacy and surveillance to the potential for technological inequality. Quantum physics isn't just a subject in a textbook. It's the key to tomorrow's breakthroughs, and it's already shaping our world in ways most people can't see. Now's the time to explore this quantum frontier. Dive into the unknown, question everything, and discover the science that's rewriting reality itself. Thank you for watching. Share your views below in the comments.